Here we go with problem 18. Okay, so this is going to be figuring out basically this car is going to be skidding down the hill and it's going to slam into the back of this car. We're trying to figure out how fast this car is going when it hits the back of this car. We're given the angle, I believe, at 12 degrees. We're given this initial distance as 24 meters, and we're given this initial speed right there as 18 meters per second. And we are also given two different coefficients of friction, one for the dry road and one for the road when it's covered with wet leaves. So I'll set up this problem. I don't know if I'll solve it for the actual numbers or not, but we can set up the problem. So looking at this car right here and drawing a free body diagram for it. So there's the car. We're going to have force of gravity going down. We're going to have normal force going up in this direction. And then we're going to have friction going in this direction. My lights just went out in the room. There we go. Sorry about that. Okay. So I got to label this as F, friction going that way. Of course, we're going to break down gravity into components. Okay, so let's see. I just had to get a different color. So we're going to break down gravity into components, which is going to be this way and this way. And we can call this Fg in the y direction, and this is Fg in the x direction. And this is theta right here. And what I'm hoping is that it's not too much of a struggle for you all to kind of get a little bit automatic with this so that we can figure out which trig function these are going to go with. So this Fgx is going to turn into mg sine theta. This Fgy is going to turn into mg cosine theta. Good. The normal force has to balance out this Fgy. So this is also going to be mg cosine theta. And then the friction force is mu times the normal force. So it's mu mg cosine theta. And the acceleration of the car is really kind of a battle between the mg sine theta and the mu mg cosine theta. So if we're going to be very formal about it, we would write our net force equation F net equals ma. And I don't know which way we want to choose as positive. To me, maybe it makes sense as positive is down the ramp and negative is up the ramp, since that's the way the car is initially going. So I'll choose my mg sine theta as positive and my mu mg cosine theta as the negative direction, and this is going to equal ma. And so obviously we want to figure out what a equals, and once we figure out what a equals, then we can figure out what is the distance that it's going to cover. Actually, what are we looking for here? What's the speed it's going to cover after it's covered this distance? So also just noting that the m's are going to cancel out. So we just get a is g sine theta minus, g, I forgot the mu. I don't have an eraser on this pencil. Minus mu g cosine theta. So you can find the acceleration, and then once you find the acceleration, actually figuring out how fast it's going at the end of that is pretty easy. We have v squared is v0 squared plus 2a delta x. I should say that presumably we're going to get a negative number for this acceleration since we want the car to be slowing down. So we want the acceleration to be in this direction, up the ramp, which we chose as the negative direction, or I chose as the negative direction. So just make sure that this ends up as a negative number inside of here and that this distance is a positive number. Since we're going in this direction, it's the positive direction. If we switch the directions around, then our acceleration might be positive and then the distance that it might go would be negative this way. Just to make sure, obviously we want this speed to be lower than this speed because we want it to be slowing down a little bit. So we want this to be a negative quantity right here. Otherwise your final speed is going to be faster than your initial speed. So I'll leave it to you to plug in the numbers, but this is the way to solve the problem.